Hello students, welcome to Laboratory D5 Parallel RC Circuits. Our circuit configuration has changed from series to parallel. Some of the computations we'll do will be very similar. We have to remember the characteristics of capacitors in parallel along with the resistors. And this is a reactive circuit because we have resistors and capacitors in the same circuit, so we will have to consider the phase angle and the J factor when we're looking at some of these other information we're doing. This is, if you look on this, this laboratory starts on page 89. The first page is just looking at your components and making sure that they are correct, doing the measurements. The second table we look at for table 4 for a VIP chart is that we're going to go through these steps in order to fill out our VIRPI chart. We're going to make sure our power supply is set for 6 volts at 60 hertz. We're going to measure each one of the voltage drops, and since this is parallel, that would be obvious what the voltage should be. We're going to measure individual branch currents. So we're going to measure the current that goes through R1 and then C1 and then R2 and then C2. And we're also going to calculate the total impedance by using Ohm's law, and we're going to calculate the power by using Watt's law. And you will need to find the theta, the power factor, and we're also going to ask you to figure out what the polar rectangular forms of this particular circuit is. And if I look at the computations of this circuit, we're going to do something very similar to what we did last time. We're going to separate the power that's across the capacitors and keep those separate from the power that's across the resistors. And that's how we come up with our power triangle over here. We have a real power of 20.4 milliwatts across the resistors. And then we have the power that is apparent across the capacitors, which is 19.92. And we're going to take that information from that we've measured. We're going to find that information, and we're going to be able to calculate and find the total current, the power factor, the phase angle, which we call theta, as well as understand and write the polar forms and rectangular forms. So if you need a review on that, make sure you look at the previous lab on D4, and those formulas are very similar, if not the same, when you're trying to find that particular information. Just want to give you a brief look at what the schematic looks like here as we put that together. We have a parallel circuit, and what I've done here is you can see that on this particular circuit is I have bussed all the lines up here on this red line for the top part of the circuit. The bottom part of the circuit is here on the other end of the source, and I've just used jump wires to make sure that we get all those particular components bussed together at the bottom and already busted together at the top. So if you have any questions once you complete this lab, make sure you look at the information they're asking you to understand. If you have any questions, your lab instructor will help and direct you on where to find that information and how to do those computations. I hope to see you in lab. Take care.